Now, the first part of the review sheet, these here, we didn't specifically cover these in the lesson, and I don't think I gave them as a homework assignment, but I still included them on the review sheet for two reasons. One, they're not actually that bad or that difficult to solve, and two, I had them on there already. So, because when we look at both of these here, really you're just solving the one side and seeing what matches up, where A is going to be the real part and B is going to be the number in front of I. So if we look at number 1, well, A is 6 and B is 7. That's it. Even with the next one, well, 6 plus 7 is 13 plus 2i. So A is 13, B is 2. Because we really just simplified the left hand or the right hand side and then got our answer. Even if we look at number 3, well, we can grab the graphing calculator because it'll deal with I. We can say parentheses 6 minus 7i plus 4 plus 2i minus 8 plus 3i. So we can type that in and get our answer. Well, I still have it in. Let's turn it back to float. 2 minus 8i is what we get. So the calculator really did the simplifying for us. And it'll tell us that the value of A is what? 2, and B is negative 8. So really we're just simplifying and matching it up is all that is. Questions on 4 or 5 that y'all want to look at? Four. So we could actually plug this straight into a calculator and it would give us the answer. If we did it by hand, we can drop the parentheses because it's plus. 9 plus 6 is 15. Negative 7i minus 3i is going to be negative 10i. So combining like terms. Now number 5, we can look at it. Now, since this is plus, we can drop the parentheses. But we can also simplify some of this here. So the square root of negative 8, well, the negative is going to come out as I. Now in the 30xs, we can plug in second square root 8 and see that it's 2 square root of 2. So negative 8 is going to be 2i square root of 2 plus. We're going to need to distribute this square root of 2, and we're going to need to do some simplifying. The first thing we're going to have is 5 square root of 2 minus, well, I know for certain I'm going to have I. Square root, we can multiply the two together, so 64 times 2 is going to be 128. Now I pull the negative out as I because it's going to be a little bit easier to work with. In the 30xs, we can take the square root of 128. Second square root 128, which didn't tell us it's 8 square root of 2. So really, we have this here is 8 square root of 2. Because we could rewrite this as 3 minus 2i plus 5 square root of 2 minus 8i square root of 2. Yeah. Now we can combine like terms. Well, make sure. Oh, yeah. Yeah, I missed the square root of 2 minus 2i square root of 2. Now, out of all 4 of these terms, there's actually only 2 that are like terms. As we can say 3 plus 5 square root of 2, because those are not the same because of the square root of 2. Negative 2 minus 8 is going to be negative 10I square root of 2. So we ended up with 3 terms. We could get 2 terms, but in order to do that, we'd have to approximate the square root of 2, and that's not making it simpler, that's just making it a little more complex. Questions on this here? I might have missed 6 and 7, but both 7 specifically, you can plug that into a calculator. Ended up being 6 can as well, because negative 9 does work in the graphing calculator. Questions on 7, 9, 8 or 9, 11 or 12. I'll tell you this much here, 8, 9, and 11, the graphing calculator will do them. You can plug them in exactly as they are, and the graphing calculator will do 8, 9, and 11. 12, the graphing calculator won't do it for us because of the square root of 7. It's not a nice number. It'll give us the decimal answer. It won't give us the radical answer. So this one here, we would have to just multiply through. 4 times 3 is 12. 4 times negative square root of 7i is going to be 4 square root of 7i. Multiplied by the square root of 7i. So we get plus 3 square root of 7i. And square root of 7i times negative 7 square root of 7i is going to be negative 7i squared. Because square root of 7 times square root of 7 is going to be just 7. I times I is I squared. And as we've seen, I squared is negative 1. So it's going to just change it from negative 7i squared to just positive 7. 12 plus 7 is going to be 19. Negative 4 square root of 7i plus 3 square root of 7i is going to be negative 7 square root of 7i. And that's it. Questions on 1 through 12? We good with 1 through 12? All right. 13 through 15. Find the complex conjugate and then find their product. Well, that's going to be 8 plus 7i. And then we would multiply the two together, 64 and 49. It's going to be 113, because we just multiply these two together and get our answer. And we can plug that in a calculator. 8 plus 7i times 8 minus 7i. We get that there, or we can just distribute out. Negative 6i's complex conjugate is 6i, and their product is 36. What's the complex conjugate of 17? 17, because we're only changing the number in front of I, which would give us 289. Questions on these here? $16, $17, $18, $19. No. Don't think so. I think they're still messing with it. So, questions on 16, 17, 18, 19. Type them in. Graphing calculator will do all of these. Even so, 17, which looks like alpha y equals enter on the right page. 5 second I over 2 plus 3 second I close parentheses squared. That's it. We could also look at 19. 1 plus second I over I minus 3 alpha y equals enter 4 minus I. Did it for us. We don't have to do anything special with these here, especially with the TI-30 or TI-84 plus CE. So make sure you definitely have those to use. Otherwise, the graphing calculators, the TI-84 plus, we have to rewrite it as parentheses being divided, or parentheses divided by the bottom, and then subtract. It's just a little more tedious typing in. Questions on 16 through 19. 20 or 21? I hope not. What's the answer for 20? 21? Because we're looking for the degree. 20 was written in standard form, 21 was not. The degree was actually 6, so we'd be looking for 6 solutions. Use the discriminant to find the number of real, imaginary, or imaginary solutions. You could also say complex, because I have a habit of saying complex instead of imaginary. They're essentially the same thing. I'm just going to pick 23, because what we're using is the b squared minus 4ac. And in our case, b is 7, so 7 squared minus 4. A is 9/4 times 12. B squared minus 4ac. And we can pick a calculator, doesn't matter which. 7 squared. On the right page. Minus 4 times 9/4 times 12. Negative 59. So that means we have 2 complex solutions. And again, the place we get that from is the fact that if b squared minus 4ac is greater than 0, we have 2 real. If b squared minus 4ac is equal to 0, we have 1 real. And if b squared minus 4ac is less than 0, we have 2 complex, or 2 imaginary solutions. So it's really just finding that value and going from there. Questions on any of this here? Questions on 25, 26, or 27? 25, 26, or 27? X squared plus 16x plus 65. One of the first places we can look is at the graph. X squared plus 16x plus 65. Graph it. Okay? That tells us, what you can see here, it doesn't cross the x-axis. So that means our solutions are not going to be real solutions. So, and since it's a quadratic, we can go just to the quadratic equation. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, the value b in our case is positive 16. So negative b is going to be negative 16. Inside the square root, we're going to have 16 squared minus 4 times 1 times 65. And it's going to be all over 2a, 2 times 1, which will just be 2. Now we can do some simplifying. So 16 squared minus 4 times 1 times 65. And get negative 4. Now we can simplify the square root of -4. It's going to be 2i, because the square root of 4 is 2, and the negative comes out as I. Now we do notice that both of the numerators are divisible by 2. When we simplify that, we'll get -8 plus or minus I. And that's it. Questions on this here? We can go and look at 27 while we're at it. Y equals x to the third minus 4x squared plus x minus 4. Graph it. Okay. So that does tell us one helpful thing, in that one of the solutions is a real number. And more specifically, it is 4. 4 is a real solution. So we know for sure x is equal to 4. We just need to find the other two. What we can do is synthetic division. 4, and then put our numbers across the top. 1 for x to the third, -4 for x squared, 1 for x and -4. 4 times 1 is 4. -4 plus 4 is 0. 4 times 0 is 0. 1 plus 0 is 1. 4 times 1 is 4. 0. So the last 0 just really tells us that's what the remainder is. We expect it to be 0, because if it is, it means it's a solution. If we plug the variables back in, the remainder, constant term, term with x squared. So what we're left with is x squared plus 1 is equal to 0. And at this point here, we can solve for x squared. Now, since there's no middle term, we can use the square root method, which is to get x squared by itself, square root both sides, telling us x is equal to plus or minus I. And we know the other solution was 4. We have 3 solutions. The degree was 3, so we expect to have 3 solutions, and these are our solutions here. Questions on this here? Yep. Questions on 28 or 29? Either one of those that y'all want to see. 29? So 29, there's different ways we can do it. One of them is we can graph it. The other is we can use U substitution and hope that this thing is factorable. Because the biggest thing with this here is seeing, are there factors of 100 that would give us, add together to give us 29? Well, 4 times 25 is 100. 4 plus 25 is 29. Now, we can use U substitution, which is just saying U is equal to x squared, to make it a little bit easier to work with. Because what that'll simplify it to, because U to the 4th will become U squared, plus 29 times U plus 100. Two sets of parentheses with 3 spaces. Now the factors of, well, since the third term is positive, our signs are the same and they match the sign of the middle term. So we would have plus and plus. Our factors of U squared are going to be U, and as I already said, we're going to have 4 and 25. Now, this here is still equal to 0 because we're wanting to solve it. We're wanting to see what value of x will make this be 0. Now, what this is really telling us is that U plus 4 is equal to 0, and U plus 25 is equal to 0. Now we can substitute x back in. So we're saying x squared plus 4 is equal to 0, and x squared plus 25 is equal to 0. Questions on how we got to this point here? Now at this point here we can solve by the square root method, minus 4 from both sides, telling us that x squared is equal to negative 4, square root, x is equal to plus or minus 2i. Because square root of 4 is 2, the negative comes out as I. Same thing for the other side, minus 25 from both sides. Tells us that x squared is equal to negative 25. Square root both sides, so x is equal to plus or minus 5i. And there are 4 solutions. Any questions on these here? Questions on 30 or 31? 30 and 31, I'll go on and just look at 30. One of the first things I do is just graph the thing. X to the 4th minus 4x to the 3rd plus 6x squared minus 4x plus 5. Graph. And it would be nice that way. So it shows us that it doesn't cross anywhere, and the only possible rational zeros are going to be 1, negative 1, 5, or negative 5, which didn't show up any of those. But what we do know is that x is equal to I and negative I because of the a plus bi conjugate, or the complex conjugate theorem. If a plus bi is a solution, a minus bi has to be one as well. So what we're going to do is, well, we set x equal to both of them, and we need to find this quadratic that gives us these solutions, divide it by the polynomial given, and then figure out what the last two are. So we have x minus I, x plus I, so we're going to multiply these together. And if we multiply them together, we get x squared plus xi minus xi minus I squared. Well, the middle two terms will cancel. I squared is negative 1. So the quadratic that gives us the two solutions, I and negative I, is x squared plus 1. So now we can do long division. And divide this thing by x squared plus 0x plus 1. Any questions on this so far? We good with this here? I might need to move all that down just a hair. So when we do this here, we need to see what times x squared gives us x to the 4th. Well, it's just going to be x squared. And you could do this off to the side, multiplying x squared by x squared plus 0x plus 1, which will give us x to the 4th plus 0x cubed plus x squared. The 0x cubed is more or less a placeholder, just so we know what's being subtracted. And then we will subtract. X to the 4th minus x to the 4th is 0. Negative 4x cubed minus 0x cubed is going to be negative 4x cubed. 6x squared minus x squared is going to be negative 5x squared. Bring down the negative 4x. We'll do it again. What times x squared gives us negative 4x cubed? It's going to be negative 4x. And if we multiply this here, we're going to negative 4x cubed plus 0x squared minus 4x. And again, we're going to subtract. 4x cubed minus 4x cubed is going to be 0. Negative 5x squared minus 0x squared is going to be negative 5x squared. Negative 4x minus 4x is plus 0x. And last but not least, we bring down the plus 5. What times x squared gives us negative 5x squared? Negative 5. And if we multiply, we'll get negative 5x squared. Make sure I copied that down right. Okay. Yep, that works. Negative 5x squared minus 5x squared is, no, that doesn't work. That's minus. Yep, looks like I'm going to have to look back at this problem. Huh? 6x squared, 4x plus 5. Yeah. Because really for this to work out, that needs to be a minus. Because 30 is not working. 2 plus I. Yeah. Make sure. Plus I minus I. Yeah. That is x squared. Yep, that's right. Because the issue is with the negative 5x, because we do have that. Ah, I see what you're saying. Yes. That should be plus. Which makes this plus, which means this should be plus. Thank you. Which is really just changing those signs. Does that make sense? Now, for this to work out and to be solutions, we have to get a remainder of 0. Yes? And that's where I was noticing my error. Because if this had been minus down here, 5 minus negative 5 would be 5 plus 5, which gives us a remainder of 10. We can't have a remainder if we know it's a solution. So, yep. So it came back to that right there needed to be positive 5x squared, not negative. So any questions on this so far? So that leaves us with x squared minus 4x plus 5. Quadratic formula. Negative b, so negative 4 is going to be 4, plus or minus the square root of negative 4 squared minus 4 times a times c all over 2 times 1. So we can simplify everything inside the square root. Incidentally, is going to be negative 4, which is going to give us 4 plus or minus 2i over 2, which is 2 plus or minus I. And we also have plus or minus I. Any questions on this here? Let's look at 31. Okay. So we good with 30? Ready to look at 31? So with 30 and 31, how many solutions should we have? 4. How many does it give us? 2. Because we know that x is equal to really 1 plus or minus the square root of 2i, because we have the positive and negative case of the square root of 2i. I could have relisted it out like I did the first one with x equals 1 plus or 1 minus the square root of 2i and then 1 plus the square root of 2i, so we have both cases. Now, I'm going to go on and graph it. X to the 4th minus 6x to the 3rd plus 14x squared minus 18x plus 9, graph. It crosses the x-axis twice, yes? Second table. Hey, and we do have 2 nice values. We have 1 and 3, yes? That's it. For this part of the homework section where it does do that, I did give you a few problems like this. Graph it. See if the other 2 solutions or the other solutions are nice whole numbers or nice integer numbers. If they are, you're done. $32 or $33, which one do y'all want to look at? Doesn't matter which. Let's look at 32, because I don't think there are many like it on the homework specifically. R, if you don't have it written down, is a squared plus b squared. Tangent is, or theta is tangent inverse of, make sure, opposite, yeah, b over a. Now, r for this case is going to equal the square root of negative 6 squared plus the square root of 2 squared. And for us, I would just grab the 30xs. I wouldn't use the graphing calculator. Square root negative 6 squared plus second square root 2 squared. Square root of 38 is our r value. Now theta is equal to tangent inverse of square root of 2 over negative 6. Second tangent inverse, second square root 2 over negative 6. So we can do, so this here is not a nice number, but we can go out 2 decimal places, say negative 13.26. Now, one thing for this here, we do need the degree positive. We need a positive degree value. So I did note for some of the assignments that you guys did this one on, we do need positive values. But also, I can't just add or take this away from 360. With some of them, it did work nicely that way. Because here, on a graph, I'm in the 3rd quadrant. Negative x, positive y. Negative a, positive b. So really what we're doing is this angle here is our 13.26. So what I have to add to it is 180. Which is going to give us 0.43742. So our angle is actually 166.74. Okay? So we can think of that angle that it gives us as more of the reference angle and then figure out which quadrant it's in. But our final answer is going to be the square root of 38 cosine of 166.74 plus I sine of 166.74. And that's it. Questions on 32 or 33? I want you to write it out, but if working later on you see RC of IS, angle is the same thing. RC is for cosine, I is for our imaginary term, S is for sine, because we know that the sine, the angle is going to be the same. They created this shorthand for it. Questions on 32 or 33? Questions on 33 or 34? Square root of 48 is probably not going to be a nice number, but the graphing or the yellow calculator is going to be nice. You make sure that you have it in the correct mode. So I'm just typing those in, because to go from complex number to rectangular form or polar to rectangular, we're really just typing in and evaluating sine and cosine. 2 square root of 3, 6, so negative 2 square root of 3 plus 6, 6i. I did it in the 30xs just on the off chance we still had a radical. Because on these here, we could do it with, actually, this one here, we could type straight into the graphing calculator and it would work just fine. Mainly because pi over 2 is 90 degrees, it's straight up, which means sine and cosine are going to be either 1 or 0. So 8, second quit, mode, radian. So 8, so your cosine of pi divided by 2 plus, all right, let me restart, because that should be a parentheses, cosine, second pi divided by 2 plus I sine of pi divided by 2 gives us 8i. Because cosine of pi over 2 is 0, sine of pi over 2 is 1. Multiply it by 8, get 8i. Questions on this here? We kind of remember these. They were nice. (36, 37, 38, and 39). 36 and 37 is multiplication. And if we remember the formula for multiplying, we multiply the r values together and then add the angles. Now, I'm not looking for decimal answers. You can leave it in polar form. But we do need to simplify a little bit. 3/4 times 4 is nice. It's just 3. Pi over 3 plus 3 pi over 4. We can grab a calculator. Pi over 3 plus 3 pi over 4 is 13 pi over 12. That's your answer. Let's flip the page. As I think we're good with multiplication, yes? Let's look at division. Now with dividing, neither one of these is nice. And when I say nice is because our R values don't simplify. We can look at 38. So we'd say 3 divided by 2, parentheses, cosine of 120 minus 40, plus I sine of 120 minus 40. 120 minus 40 is 80, plus I sine of 80. Because with division we subtract. With multiplication we add the angles. And that's it. Now if you wanted to, just go on and simplify 120 minus 40, because you knew that's what we were going to do. You can do that, get your answer, and you're done. Questions on these here? 40 and 41, I'll look at 41, because the formula for this here is r to the n times cosine of n theta plus I sine of n theta, where n is the exponent that we're using. And you have to have it in polar form to do this. Now 2 to the 8th is going to be a decently big number. It's not going to be outrageous, 256. So we can plug that in a calculator, let it do it for us. Now we can do 8 times pi over 2, which is going to be 4 pi times I sine of 4 pi. And that's it. Now this one here, I will look back into these and tell you, I believe specifically I have in the directions. If you can leave it in polar form or want to go all the way down, I will clarify that tomorrow for sure. And the only reason I say that is because cosine of 4 pi is 1. Sine of 4 pi is 0. So really this simplifies to 256 if we multiply it out. Because it's really just going to be 256 times 1. Does that make sense? Now on the last one with the division we had 80, which is not a nice number. I don't think the... Yeah, so 40 we went on and simplified it. I gave you the simplified versions of 36, 37, 38, 39, and 40. I did go on and simplify those for you so you could see them, but that's it. Do y'all want to look at 42 or 43? Which one do y'all want to look at? 43. One thing we'll need to do is convert. Really, we're going to have 4 times this here. So we'll need to get it in polar form. I know the bell's about to ring. So we'd have 1 squared plus negative square root of 3 squared. Now this looks like it's going to give us a nice number, second square root of 1 squared. As I throw this on the floor. There we go. Plus, parentheses, second square root of 3 squared. I know that's supposed to be negative, but the square will make it positive. And we get 2. Well, might as well. Let's see here. Yeah, negative second square root 3. We still get the same value of 2. So that's kind of nice. R is 2. Theta is going to equal tangent inverse of negative square root of 3 over 1. And again, we can leave it in degrees. Second tangent inverse. Negative second square root of 3 over 1. This one we definitely need the sign, so we get negative 60. But thinking about the quadrant plane, positive, negative, we are down here. So we add 360 to it, which tells us our angle is actually 300 degrees. So what we have is 2 cosine of 300 plus I sine of 300 to the third. So we have 2 to the third times cosine of 3 times 300 plus I sine of 3 times 300. Well, 2 to the third is nice. That's just 8. Cosine of 900 degrees plus I sine 900 degrees. I probably need one more parenthesis. Yeah. But the last thing we can do is multiply. 8 times 4 is 32. Cosine of 900 plus I sine of 900. And again, I will specify if you need to take it further than this, and really taking it any further than this is just typing it in cosine of 900 degrees. Cosine 900, negative 1. So we could say 32 cosine of 900 degrees is negative 32. 32 sine of 900 degrees is 0. So really, this just simplifies to negative 32. Questions on this here? 44, 45, 46, 48. Okay, now, before I let you all go, because I know we're going into lunch, are there questions about finding the roots of complex numbers? Or do y'all feel comfortable with those? Because I will give you this here. Because z sub k is equal to the nth root of r cosine of theta plus 360k over n plus I sine of theta plus 360k over n, where n is our root and k is equal to 0, 1, 2, going up to n minus 1. Okay. What we can do is, I think most all of y'all are going to be here the rest of the week, yes? We'll go over one of each of these, one of this one of the next, and one of the last type tomorrow, if that's fine with y'all. And then I'll go on and give you your test. Okay? That way we're not technically wasting a day, but you have a half of tomorrow, or the good part of tomorrow, and the next 2 days to work on it.